Students, this is the second in the series of 3 videos on factoring. This one specifically deals with the 2 different ways to factor trinomials. Just the brute force method, which I tend to prefer, frankly, and what I've referred to in class as the critical integers method. Okay, let's look at our first trinomial. This is actually the most complicated, I think, of all the types of factoring you're going to be required to do. And there's a couple methods that I want to show you. First of all, I'm just going to do a standard factoring here. I've got a trinomial. I know that when I factor it, I'm going to actually have 2 binomial factors. And what I need to consider is the possibility of the first terms, which multiplied together give me the first term, and the last terms of the binomial, which multiplied together give me the last term of my trinomial. So in this case, my coefficient of my x squared term is 16. So my first terms, my possible coefficients of my first terms in my binomials, I could have 1 times 16 is 16, 2 times 8 is 16, or 4 times 4 is 16. Now my last term is a little simpler. It's a 15, and that can either be a 1 times 5 or a 3 times 5. Now keep in mind that these last terms could also be reversed. Instead of 115, I could put 15-1, which would give me a whole different pair of binomials. But again, let me emphasize, and I showed in class, I never switch the first terms, only the second terms. So let's take a look, and let's just try it one step at a time. And in this case, I've chosen to start with 4 and 4 as my coefficients. Truth be told, I think this is what most students would gravitate toward, so that's the reason I picked it. Next thing I have to consider is what the signs will be. If I go back to my original trinomial, I want you to notice that it was negative 15. Well, the only way to get a negative 15 would be a positive times a negative. Now, observe that if this had been a positive 15, there'd be 2 ways to come up with that. Either I could have a positive times a positive, or a negative times a negative. And how I determine which of those I would have to have, I go back to my original trinomial. In this case, you'll notice that the middle term is positive. That would indicate that both terms would have to be positive. Had this been a negative, both terms would have to be a negative. But in this case, again, it wasn't an issue. I needed a negative 15, so it was simply a positive times a negative. Now, for no other reason than I'm just going to go from top to bottom, I'm going to pick the 1 first and the 15 second. Let's now try and see what happens when I take my inside terms and multiply together. I get a 4x. I take my outside terms and multiply together. I get a negative 60x. Well, unfortunately, that would be negative 56x, which is way off from my 34 that I needed to have for my middle term. Now, to be honest, you probably could have even seen that that was not going to be the answer just from looking at the problem. But just for the sake of doing every single possibility, I went ahead and gave it a try. Now, let's go ahead and take a look at another possibility. In this case, I simply chose to reverse the 15 and the 1. Remember, the last time I tried this, I tried the 1 first and then the 15. So in this case, I'm going to try the 15 and then the 1. In this case, let's try it quickly again, and I want you to observe that this would be a 60. This would be a negative 4. Well, that would give me positive 56. Obviously, that was what was going to happen. And obviously, I didn't really have to try it. But again, just to make sure that you've seen every possibility, I want to try them all. So it's not the 1 and 15 for the last terms. I've tried it both directions. Let's try the 3 and the 5. If I take my 3 times my 4x, I get 12. If I take my 4x times my negative 5, I get negative 20. That would leave me with negative 8x. Also not the 34 I'm looking for. So let's try reversing it. Let's try putting the 5 first and then the 3. And I'm sorry, I don't have to try that because I know, as in the last example, that it's not going to work. So I take it back. I'm not even going to waste your time trying that. I'm just going to move on. I've tried both possibilities, 115, 15-1, and the 3-5. Admittedly, I left out the 5-3, but it would not work. So I know it can't be any of those answers. But I've tried every possibility with 4 and 4, so I'm going to move on now and try the 2 and the 8. The first one I've substituted in here is the 1 and 15 again. Let's try it and see what happens. I've got the 1 times 8 is 8. The 2 times negative 15 is negative 30. Well, that would leave me with negative 22, and it still doesn't work. So let's switch the 15 and 1 around and see if it's different this time. Since my first terms are not the same, this will absolutely change the answer this time. When I multiply the 15 times the 8, I'll get 120. And when I multiply the 2 times the negative 1, I get negative 2. Combining those would leave me with 118, which is obviously not the right answer. And again, if it was obvious to you, you didn't even have to try it. But let's switch them now. It's not 115 or 15-1, so let's try the 3-5. The 3 times the 8 would be a 24 for a middle term. And the 2 times the 5 would give me a negative 10. If only it was a positive 10, it would have worked. 24 plus 10 would indeed give me 34. But since this was a positive 24 and a negative 10, that would give me a 14 and not the 34 again that I'm striving for here. So let's try the last one. Let's switch the 5 and the 3. If this does not work, that means I'll have to resort to trying my third remaining first possible pair, which would be 116. So let's hope that this works. If I take my 5 times my 8, I get a positive 40. If I take my 2 times my negative 3, I get a negative 6. And lo and behold, 40x minus 6x does indeed leave me with the positive 34x that I wanted. So this is indeed my answer, and I've correctly factored my trinomial. I'm going to redo the last problem that I factored. It's exactly the same problem, but I'm going to show you that second method I talked about. This method is what I refer to as critical integers. And in this case, I'm also going to use, well, in every case when I factor this way, I'm going to use a grouping technique, which you're also going to need to know how to do in order to be able to factor your polynomials. So in this case, I look at the middle term, 34. And what I want to do is split this middle term into two coefficients, who in this case add up to positive 34. I'm going to call them R and S, which is exactly what your book calls them. And I'm going to say that R plus S must equal that 34. Now, I'm going to take the 16 and I'm going to multiply it by negative 15. And what I know is that that same RS, when multiplied, has to give me the same product as 16 times negative 15, which is negative 240. So I'm looking for two numbers, R and S, that add together to be 34 and multiply together to be negative 240. Or if you want to be a little more technically correct, they have a sum of 34 and a product of negative 240. So let's try the easiest thing I could think of. Notice that one of the numbers must be positive and one must be negative, because R times S has a negative product. So in this case, I'm going to use 35 and negative 1. Adding those together, 35 plus a negative 1, which frankly is just 35 minus 1, is 34. That part works. Let's try the product. 35 times negative 1, negative 35. Way too small. So let's try a bigger number. So instead of 35, let's try 50. 50 minus 16 would also give me the 34. Let's try my product. 50 times negative 16 is negative 800. This one's way too big. So let's try something that's smaller than 50 and yet bigger than 35. In this case, I've chosen to try 38. 38 minus 4 would give me the 34 that I need for the sum. Let's multiply the 38 times the negative 4. That gives me negative 152. I'm closer, but I'm still not quite up to negative 240. So let's pick a larger number here. Let's pick 42. 42 minus 8 would still give me my 34 that I need. The product of 42 and negative 8 gives me negative 336. A little too big. So now I need to go smaller. Notice that I'm just narrowing the range. I started knowing between 35 and 50. Once I observed that 38 was still too small, I knew it had to be between 38 and 50. So I tried 42. 42 is too big, 38 is too small, so I know it's between 38 and 42, and let's try 40. 40 times negative 6, 40 minus 6 is 34, and 40 times negative 6 actually gives me that target of negative 240 that I wanted. So the two numbers I need are 40 and negative 6. Let's split that middle term up now. I'll keep the 16x squared, but I'll split the 34x into 40x minus 6x. And then, of course, I'll keep the last term intact, negative 15. Now, let's group. Let's split them and look at just these first two terms. What term is common to both of them? Both 16 and 40 are divisible by 8, and both terms have an x. So I'm going to remove 8x from that binomial, which will leave me with 2x plus 5. Now notice that in my second pairing, my first term is a negative. You never want the first one to be a negative whenever you're factoring. That's a common rule. So I'm going to factor out that negative. In addition, 6 and 15 are both divisible by 3, so that means I'll factor out negative 3, my common term. That leaves me once again 2x plus 5. Now notice that both binomials that are left are identical. That should always happen. If it doesn't, you're in trouble, because my next step is to factor out from both these terms the common term that I see. And what they both have is the binomial 2x plus 5 in common. So I'm going to factor out that 2x plus 5. From the first term, that leaves me an 8x. From the second term, that leaves me with a negative 3. And once again, I've arrived at exactly the same solution that I had by my first method.